Hey, hi. So this video here is going to be more of a visual uh, video. I printed out some visual aids with one of the research papers that served as a kind of reference for the last couple of videos I did on biofeedback and some of the topics in there. This paper was called The Flexibility of Thought in High Creative Individuals Represented by Percolation Analysis. So that's on the PNAS. I'll put that it's on there. You can look it up, link or whatever. Um, so, percolation analysis. You know, I've read a handful of papers on this. I don't really see too much difference in the papers I've read between percolation analysis and any other kind of analysis. Percolation analysis, it's being used in a lot of fields, like maybe all fields pretty much. People are using that word or those two words in a lot of areas now. So now I've mostly read papers with the percolation analysis in the title well, the few on neurology is a couple I read on biology, some evolutionary biology, um, you know, more in that area. I'd say biological, chemical based type things, but they're using it in computer science and all kinds of other areas, engineering. You know, I just don't really see much difference myself, just from what I've read. Um, so what you'll see in the definition, if you look it up, most commonly, percolation, just like it describes, you know, like like a coffee pot, percolating, goes through a filter, and that changes the distribution of, you know, the water, coffee beans, the coffee grounds. Yeah, it changes, goes through a different medium, and the distribution of things change. I don't think that's so much different than other ways that we've been looking at how variables change under different conditions. It's got a nice new name for it, I think, as far as I've read. Um, it is a nice name. It is very descriptive. You know, I mean, that is a good way to analyze, you know, how things do change when you put them through a different, you know, uh, application or medium of some variables. See a different distribution. That's a great name. Too bad they didn't come up with it earlier, but we have it now. Anyway, um, now the reason I really got into this, the definition I first read said that you see these tipping points of things, which is that there's a small change somewhere, and then it creates this huge cascade of effects. I thought that was really interesting, these tipping points. I haven't seen that so expressly put in the studies, though. We just see these different distributions. Here, I'm going to put up a little graph here. We'll take a look. This is from the flexibility of thought. So let me just describe that again. I mentioned it, at least in one of the previous biofeedback thinking. And so what they do is they do have a slightly new way to organize and reveal, reference how people think. So, and how to characterize that. So they do it. This study did it in terms of uh, the diversity of word usage and concept usage. So you might recall that from some of the previous ones. Um, so previous to that, before word concept diversity, they would just use more subjective indicators, or some objective indicators would how someone performed when they were switching tasks. So that was thought to be like a measurement of someone's flexibility in their thinking. They could switch tasks and still solve problems fairly well. But now that's an objective measure. I think. Um, well, no, it's actually still indirect because you're measuring uh, the how well they perform at different tasks. The word and concept usage measurement, I think, is maybe like an order more closely resembling the internal dynamics. But you can read for yourself. So anyway, here's the first graph. Okay, here it is. Okay, so this, we'll get back here. Oh, there. Yeah, I don't know. Something like that. It's probably a little blurry. Okay, now they look fairly similar, right? I mean, this one on this side here, this is the high creativity side. This is more the people that have less flexibility in their thinking. Little hard to say, okay? First off, I could give you some tips, right? But let's look at the next one where this one, so now it's really obvious. What they did for this is they just counted the number of interconnected networks, right? So you can see high creativity, greater flexibility, greater diversity of word usage, lots more interconnections, right? So if we go back to this one, now you can kind of see. So what's the difference? Well, you can kind of see the only thing, these are a lot smaller. This side here, right? A lot smaller. So that might indicate they're more dense, but you might not get that. I don't know. They do look kind of different, right? I mean, you can see now this one on this side has those blue clusters in the middle. Those belong to this one, those isolated little clusters. That's kind of the first indication that of the sort of breakdown of the system. Isolated little clusters. Yeah. So anyway, so kind of interesting. Okay, there's that one. Okay, so now on the bottom one here, what we have is above the line, interconnections, connectivity, and the high density above the line, I mean high creativity from this side over here above the line, and below that, below the line, low creativity, lower connectivity, right? So much less connectivity. There's only 2, 4, 6, 7 dots below the line. Not much happening there. I can't count how many that is real too quick. Who cares? But it's a lot more. Although we always count shit in science, so let's see, we got 4, maybe 6, 8, 10, maybe 12, 14, 16, 18. So 18 versus, what was that, 8, 4, 7. 18 versus 7. That's more than double. Anyway, so then I thought we'd jump to this. Any questions on those? Let me see. Percolation theory. Yeah. Can't really see much of like a tipping point though. I mean, that was the interesting that got me first was, I was saying, wow, you can find that one little point where one little thing changes the entire field. Haven't really found that. It's just an analysis of variables, a comparison of variables again. I don't know. Seems similar to me. Anyway, this one. Now these, okay, we'll do them one. This top one, you might be able to see the sort of lower one that looks a little lighter. I don't know if you can tell. That is actually dots, and so but it looks pretty interconnected. Well, if you go look at the paper, it's better picture. And then we have the sort of higher one more to the right. That's solid line. The only thing I really notice here is that the one those lines kind of hard to see on here, but those lines on the right one have a lot more smaller steps. I thought that was interesting, especially in that one area. The what is that? The number. What does that say? Number of nodes and the threshold. Hmm. The threshold. We'll probably see. Let me see. This is okay. The threshold has to do in the equation that they're using to get these out of the data. It's a Gaussian model. Uh, so it's called noise, Gaussian noise. That's the equation that they used, and that Friedrich Gauss. We use a lot of his theories. A lot of people hate. No, a few people hate a lot of his theories. uh, but they're interesting. He was the one who did the magnetic field equation that we call, magnetic field could be 100 Gauss, 2000 Gauss. That's the strength of the magnetic field. Anyway, if we go up this one, now you can see, okay, this Gaussian noise. Does it say that on there? No. Oh yeah, it does say noise. So this one you can see, if you can read it. It says noise there in the box. Get this on text for the video. Okay. Anyway, so Gaussian noise, they're applying that. So you can see when they apply the noise, these things separate a lot more. So we've got the high with noise off, low with noise off, high with noise on, low with noise on. So kind of the number of steps varies. The blue one, just looking as the most steps, looks like the blue one is, yeah, that's a high creative without noise. So it just kind of shows you some more features. So this noise, this noise concept, and that's an equation that let's see, they probably use several equations of Gaussian analysis methods, and they just reveal some more properties. It's just like this is like a percolation analysis within the percolation analysis. We're just applying another field, another medium distribution effect to show how that medium affects the numbers. So the first field is that we're taking data from word and concept usage from two different groups, okay, and then we're comparing their word and concept usage. So that is the percolation field. That's the first one. We put them through the analysis of word and concept usage, and that reveals these different networks. I like the term myself, percolation analysis. It's cool. It sounds very technical, savvy, modern, hip, up to date. Anyway, let's see. What else do we have here? Well, we have this bottom one, another HFC, nodes and threshold. Again, they didn't mention this in the article. But I'm going to bring this up in another video too. Let's see, how long are we on there? 13 minutes. Okay, here. So this one, so this is the bottom graph. Again, this is just, this is without noise. This is just a comparison. Not sure what the difference is here, that separates it from this one. Number of nodes and threshold. Number of nodes and threshold. What is it, higher? Let me see. 0.1, 0.5. No, same. Pretty much the same. I forget what the difference is. But the one thing I noticed again, okay, the one with the smaller steps, that's the darker line, right? That's a high creative one. See, I just noticed, because I've seen that in other research and graphs and biofeedback too, where you see these the difference between different parts of the biofeedback process. You see these different combinations of steps and lines. Seems to be kind of a biological process that things process in either shorter, more frequent steps. I try to make that point in the videos a little bit. And then you have, less frequent steps and less frequent changes, bigger steps less frequently, or smaller steps more frequently, seems to be a property of, certainly in this study, of the high creative group. They didn't mention that in the paper, really. They mentioned a lot of other things that I also kind of mentioned. I'm sure I didn't get everything. There's a lot of math in these studies. I don't really get all the math. I get some of the math. I'm not that advanced in math to be able to do one of these. I couldn't do the whole thing myself. I get some of the beginning properties, which I'll maybe do a video on that to show how they get some of the basic starting points to do the math